Hi guys, my name is Rishi and I'm the founder of Tutoring at its Best. In these videos, I will be going through exam pass papers, topic papers, focusing both on areas where you can excel for the GCSE exam. So what is my reason for making these videos? Well, I think we've all faced a time in our studies where we need explaining twice in order to grasp the understanding of a topic, whether it be about rock cycles, balancing equations in chemistry, or even solving simultaneous equations. I feel that learning should be enjoyable and building a sense of confidence, accomplishment, and self-esteem, as well as my objective for teaching students to improve their self-discipline and self-motivation. So my main objective is to teach you how to learn, how to structure your thought process, and tackle a task by breaking it down into manageable steps, and how to confidently structure and communicate your thoughts under exam conditions. So I hope you will gain a lot of confidence and knowledge around the topics that I will be demonstrating. And don't forget, my aim is to also have some sort of commonality with you all, because that's usually what brings together that communication. I have the relevant experience and knowledge, which can make you head in the right way. And I've also gone through the same process of taking GCSEs and A-levels and was once in your position. So I totally understand that it can be a daunting experience, but at least you can learn from my mistakes and learn the tips and tricks of getting the full marks. So without further ado, the test paper shall commence. Wonderful. So in today's video, I will be going through a paper 1 non-calculator. You can see it's the 2019 paper here, and it's for the foundation tier. I'll be going through each individual question, and I will assume that you have some background knowledge on these topics, but I will provide a detailed explanation for each individual question. So let's go ahead and get started. So let's dive into question number 1. And this is asking us to write 180 minutes in hours. So again, the first thing to understand here is that there are 60 minutes in 1 hour. So let's go ahead and write that out. 60 minutes equals 1 hour. And then I need to find out how many times is 60 going to 180. So then I simply write 180 divided by 60. And we know that 6 goes into 18 3 times. So if I cancel this out, and that gives me 3. So our final answer is 180 minutes is 3 hours. Over to question number 2. It's now asking us to write 0.73 as a percentage. And again, the conversion between a decimal and a percentage is, again, multiplying by 100. And that's if you're diving in from a decimal over to a percentage. So once again, we take our 0.73 and we multiply this by 100. We know that means we need to jump to the right by 2 spaces, and that leaves us with 73%. And then moving over to question number 3. Again, this is a question around BIDMAS, where we have a range of different operations that we need to follow and in a specific order. So the first thing within BIDMAS is your brackets. So we'll go ahead and calculate 3 plus 5, which gives us 8. And then we'll go ahead and multiply it by 10. So 10 times 8 gives us 80. And then question 4 is now focused around your prime numbers. And that is, again, the prime numbers that are between 20 and 30. So what is a prime number? The first rule of a prime number is that it can only have 2 factors. And that is, again, 1 and the number itself. So we'll go for 2 factors. The second rule is that 2 is the only even number that is a prime number. So 2 is the only even number that is a prime number. And finally, the third point is that 5 is the only number ending in 5 that is a prime number. So again, we'll just keep 5 there, ... So now we need to go ahead and write down all of the numbers between 20 and 30, and let's eliminate them as we go on. Okay, I've now written down all of the numbers from 20 and 30, and let's go ahead and follow the 3 rules to see which number gets eliminated. So the first thing I'm going to be going through is again finding out all of the even numbers and eliminating those. So I'll go ahead and eliminate my 20, 22, 24, 26, 28, and 30. We're then going to look at those numbers which have two factors. We'll start with 21. We know 21 has more than two factors as it's both in the 7 and the 3 times table, so we can eliminate that. 23, on the other hand, does have two factors, which is 23 and 1, so we can now circle that. 25, on the other hand, goes against our third rule, which is that 5 is the only number that ends in 5 that is a prime number, so we can cross that out. 27, on the other hand, has 3 and 9 as factors, so again that's more than two factors, so we can cross that out. However, finally, 29 is actually a prime number as it has two factors, and that's 1 and itself. So again, as it asks us to write down a prime number, it can be either 23 or 29. I'll go for 23, and let's now move on. Wonderful. Question number 5. So this is where we need to find the number that is exactly halfway between 7 and 15. So we know there's two numbers that we're working with, so we will have to split the two numbers up and simply divide them by 2. So let's add up our numbers and then divide it by 2. So we know that gives us 22, and once we half it, it gives us 11. So the number exactly halfway between 7 and 15 is 11. And again, a way to check that is to see if the difference between the smallest number and the largest number is the same. So let's go ahead and simply have 11 take away 7, which gives us 4. And let's go for 15 take away 4, which gives us 11. So you can now see it works both ways. So if we have 11, we can add 4 to that to get 15. And again, if we have 11, we can take away 4 to get 7. So in question 6, this is now a problem-solving scenario. We are told here that Harry is planning a holiday for 4 people for 7 days. And we're told the costs for each person. So we know it costs £150 for each person for 7 days for travel. But for hotel, we're told that it's £50 for each day. So we need to now multiply that by 7, and that giving us £350. So we know for 7 days, it will cost £350 for the hotel for 4 people. And then finally, we know that it's £250 for our spending money. So now we can go ahead and add up the total cost. So we have 150, we have 350, and we have 250. And if we add that together, that gives us 750. So now we know it costs £750 per person. We now need to multiply that by 4 because we need to work out the total cost for 4 people. So again, let's go ahead and multiply 750 by 4. We know that 0 times 4 is 0. We know 5 times 4 is 20, so we'll carry that 2. And we know that 7 times 4 is 28. And if we add that 2, that gives us 3,000. So all in all, it will cost us £3,000 for the holiday for 4 people and 7 days. Over to question number 7. In Adam's garden, the flowers are only red, white, yellow, or blue. And we have a chart to show us a visual representation. And we now know that the total number of flowers is 30. So let's work out the number of blue flowers. So the first thing we're going to do is find out the number of red flowers, which is 8. We know the number of white flowers is 10. And we know the number of yellow flowers is 5. So let's go ahead and add that up, and that gives us 23. We then need to go ahead and subtract that from 30, and that gives us 7, which again is our answer for the number of blue flowers. And then part B asks us to write down the mode. And the mode is now seen as our most common. And we know from looking at our chart above, the most common is our white flowers. So that is what our answer will be, since that is the most popular flower. And then if we move over to question 8, this is a very interesting question, as we have a number of different fractions with different denominators, and we'll need to put them in order of size, starting with the smallest. So that means we need to take a look at our denominators and find one number that all of these numbers go into. And again, you can see that 3, 4, 12, and 2 are divisible by 12. So I'll simply go ahead and multiply out these denominators until I get 12. So let's go ahead and times the first 3 by 4. And remember, if you multiply the denominator by a number, you have to multiply the numerator by the same number, which means I'll be multiplying 1 by 4. And that again gives me 4 over 12. I'll do the same for 3 over 4, but this time I need to multiply it by 3. And that again gives me 9 over 12. And then again, I'll multiply that by 3, and that gives me 3 over 12. But for the fourth one, which is 7 over 12, we can keep that the same. And then finally, we know 2 times 6 is 12, so 1 times 6 is 6. And that gives us 6 over 12. So that's our first step done. The next step, we simply have to go ahead and order these from the smallest first. So again, we know that 3 over 12 is the smallest. So again, that will be our quarter. We know the second smallest is 1 over 3, which is 4 over 12. And then we know our third is a half, which is 6 over 12, before we finish off with 7 over 12, and then 3/4. And that is all that we need to simply do. And now moving over to question number 9. This is a question which is based around your distance, speed, and time. We know that Ruth left home at 9 a.m. and she got to the library at 10:30. So again, if we take a look at the distance between 9 and 10:30, we know it's 1.5 hours. We also know her speed, which is 4 miles per hour, but we don't know her distance. So let's go ahead and write down distance equals speed multiplied by time. And we have our speed in time, which is 4, and our time of 1.5 hours. So if we multiply that together, we get our distance, which is 6 miles. And that's what we are going to write there. However, in part B, it now states that Ruth got to the library at 10:30, and she stayed there for 15 minutes. So again, let's start off by writing 10:30, and let's add our 50 minutes, giving us 11:20. And then she goes ahead and walks home. And it takes her 1 hour and a quarter minutes to walk home. So again, let's go ahead and add 1 hour, which gives us 12:20. And we need to find out what a quarter is out of an hour. So again, a quarter of 60, because there are 60 minutes in an hour. Again, with this question, there's a 2-step method where you divide by your denominator and multiply by your numerator. So let's go ahead and divide 60 by 4, which gives us 15, and then multiply that by 1, which gives us 15. So then we go ahead and add an additional 15 minutes onto this, and that gives us 12:35. So what time did Ruth get home? That's 12:35. Marvelous. Let's now move over to question 10, which is around simplifying variables. So again, algebra related. And I know many students now become nervous when they see questions like this because they see a random variable and they don't know what to do. But I assure you it's very simple. So let's give this question a go. So we now need to solve t, and we know that we have 3 t's which give us 12. So we can simply start off by 3t equals 12, and then simply dividing 3 from both sides, so we're left with t, which gives us 4. So 12 divided by 3, giving us 4. So again, as you can see, 3t was seen as 3 multiplied by t, which gives us 12. So if it's a multiplication and we take it on the other side of the equal sign, it then becomes a divided by 3. And so likewise for this question here, part B, we have a -2. But if we take that -2 to the other side, we now have a +2. So we now know that x would equal 8. So let's put that there. Before moving over to part C. And with part C, it's the same principle. We start off by subtracting 2 from both sides. So now we have 6w equals 18. And remember in part A, 6w, when we had a number and a variable and it was together, this meant it was a product, so the multiplication. So we're now going to divide 6 on both sides, and we get that W equals 3. Okay, let's move over to question number 11. Almost there, guys. Let's keep up the good work. And this question, we need to use the column method to simply multiply 74 by 58. So again, I'm going to use a different color for this. And the first thing we're going to start off by doing is multiplying 4 by 8, which gives us 32, and then 7 by 8, which gives us 56. And then if we add that 3, that is 59. We then go ahead and put our place value holder, and let's go ahead and multiply 74 by 5. So again, 4 times 5 gives us 20, and then 7 times 5 is 35, plus the 2, which is 37. And then we can go ahead and we can add that up together. So 2 plus 0 is 2, 9 plus 0 is 9, 5 plus 7 is 12, and then 3 plus 1 is 4. So our overall answer should be 4,292. And again, please remember that we have to put in a place value holder as we're now multiplying 74 by the tens position, which is 5. But in the case of the question, it would be 50. Okay, let's go over to question number 12, which is around angles. So again, AB and BC are perpendicular lines. And again, perpendicular is when we have two lines meeting together at a 90-degree angle. So we now know that the total of these three angles equals 90 degrees. We have two of these angles, again, which is 25 and 25, which gives us 50. And we now need to subtract 50 from 90 in order to get our answer. So 90 take away 50 gives us 40 degrees. So we now know that the value of x is 40 degrees. And now moving over to the part B question. RS and TU are parallel lines, and PQ is a straight line. They've given us one angle, which is 125 degrees, and they're now asking us to pick a letter of another angle of the same size, and then give a reason. So the first thing we can take a look at is that opposite angles are the same. So again, we can write it that B is an opposite angle and that it is equal. But there's also another letter, and that would be letter D. And the reason being is that this would be corresponding angles. And again, you can see that corresponding angles are equal. That is because we can draw out an F angle. So if you take a look here, we can now see that this angle here is the same as this angle here. And that is your corresponding angles. So if you choose either one of these, that would give you full marks. And then finally, we need to ask why A, B, and C equal 235 degrees. So we know that these four angles will equal to 360 degrees. We know B is 125 degrees. And because they are opposite angles and they're the same, that means that A and C must also be the same. So what can we do here? We can simply go ahead and subtract 125 degrees from 360. And if we get the same answer, which is 235, then we know it's correct. So let's go ahead and subtract 125 from 360, which, yes, does give us 235 degrees. And that is because angles around a point add to 360 degrees. Okay, beautiful. You're doing really well. Let's now jump over to question 13, which is again, algebra as an expression. So they've told us that the length of a line is x centimeters, and they want us to express this in millimeters. So the first thing we need to do is look at the conversion between centimeters and millimeters. So from what we know, we can say that 1 centimeter is equal to 10 millimeters. And because we don't know the current length of a line, we can simply present this as x multiplied by 10 or 10x, and then write that down as our answer. So for instance, if our length of the line is 5 centimeters, we can simply multiply this by 10, which will then give us 50 millimeters. And then moving over to question 14, this is a similar question to what we've done in our previous questions. So this is again the two-step method where step 1, you need to divide your number, your amount, by the denominator, and then multiply it by the numerator. So again, 70 divided by 5. Let's go ahead and work that out. Remember now, because 70 is a numerator, that will go under the umbrella or the bus stop, as they say. Let's see how many times 5 goes into 7. We know it goes into 7 once with a 2 remainder. So again, we can put 50 here and then take it away, which gives us 20. And then how many times does 5 go into 20? And that is 4. And overall, our answer is 14. And I know we need to multiply it by 1, but it's the same. So we can simply write 14. However, it states that Fiona has to work out the exact value of 48 divided by a half. And so she writes that 48 divided by half is 24. And her reason is that there are 2 halves in 1, so there will be 24 halves in 48. Well, we know that there are 2 halves in 1, but that doesn't mean that there will be 24 halves in 48. So what's wrong with her reason? Well, the first thing is that there are 96 halves in 48. So how did I find that out? Well, the first thing is, if you are dividing it by a half, you don't simply do the same method where you're divide it by 2 and then times by 1. That is because we've got our division method here. So what we're going to simply do is do the opposite, and that's timesing it by 2, so timesing it by a denominator, and then timesing it by 1. So again, 48 times 2 gives us 96, and then if we divide that by 1, that still gives us 96. So that shows that there are 98 halves in 48. So what did Fiona do? She divided it by 2, not divided by a half. So she should have simply doubled 48. Spectacular. Let's go over to question number 15. And that is writing down the value of square root of 64. So square root is where we would get one number that you multiply by itself in order to get a larger number. And then the square root is where we do the inverse of that. So we need to find one number, which in this case we know is going to be 8. And if you multiply it by itself, it should give you 64. So the value of the square root of 64 is 8. And then again, if we take a look at our powers, the second question asks us to cube 5, which means we're multiplying 5 by itself 3 times. So we know 5 times 5 is 25, and then 25 times 5 is 125. We can simply write that down in our answer box. Okay, we're now moving to expanding our brackets and factorizing. So simply, we can multiply 5 by 2m, which gives us 10m, and 5 by minus 3, which gives us minus 15. And that's written out there. However, for part B, we need to do the reverse order. And that is where we're finding out one number that goes both into 3 and 12. I'll go ahead and write 3 because 3 goes into 3 once. So I can simply write n, and 3 goes into 12 4 times. So when I expand the brackets, 3 times n is 3n, and 3 times 4 is 12. So we can simply write this down, which is n plus 4. I'm moving over to question number 17. So again, this is now based on probability. We know that Stuart throws a biased coin 10 times and he gets 7 tails. And Maxine throws the same coin 50 times, so he's thrown it 5 times more than Stuart has, and she gets 30 tails. And Prasha is going to throw the coin once. So whose result will give the better estimate for the probability? Is it Stuart or Maxine's? So again, you need to think about how many times each of them have thrown the coin and then make a decision. And we know that Maxine has thrown the coin 5 times more than Stuart. So in this case, it's going to be Maxine, because the more trials, the better the estimate. Spectacular. However, it states that we need to use Stuart and Maxine's results to work out an estimate for the probability that Prasha will get tails. Now we understand that she's gone ahead and thrown the coin once. So many would think, oh, it's 50%, but that's not the case. In order to estimate this, we need to use Stuart and Maxine's results. So again, we can see that Stuart has thrown the biased coin 10 times and gets 7 tails. And Maxine has got 30 tails. So we add that together which gives us 37. And we see how many times that they had both thrown it. We know Stuart threw the coin 10 times and Maxine threw it 50 times. So we'll do 10 plus 50, which gives us 60. So the probability that Prasha will get tails is now 37 out of 60. Okay, let's move over to question number 18. And this is where the diagram now shows a rectangular garden path. Now Wasim is going to cover the path with paving stones. And each paving stone is a square with a side of 30 centimeters. So again, we're going to find out how many 30 centimeters paving stones can fit in our length and our width. So let's go ahead and divide 600 by 30. We can again cross out 1 0 from the top and 1 from the bottom and simply divide 60 by 3, which gives us 20. So now we know we can fit 20 paving stones in our length. We'll then go ahead and do the same by doing 120 divided by 30 and take a 0 out on each end. And that again would give us 4. So we now know that we can have 4 slabs on our width. Having said that, we are now going to multiply out our 4 by 20 to get the total number of slabs and paving stones that we need. So let's go ahead and multiply 4 by 20. That's our first step. That's our second step. We now need 80 paving stones in total. And we know that each paving stone costs £2.50. So let's go ahead and multiply this out. 80 times 2.5. Again, we can do 80 times 2, which is 160. And then a half of 80 is 40. So we know if we add that together, we get £200. And we have to simply show that he has enough money to buy these. And we know he has £220. So overall, we know that 200 is less than 220. So yes, that is our proof done. And that is our question complete. And let's now dive into question 19. Okay, and this is now a fraction question. And throughout my entire time as a tutor, I've been sticking to the main method of the butterfly method. So let's show you how that is done. So we simply write down our fraction, but this is where you cross multiply. So we multiply 2 by 5, which gives us 10. We then multiply 1 by 3, which gives us 3. And then finally, the below, which gives us 15. And then by writing this out, the denominators are now the same, and we can simply go ahead and subtract 3 from 10, which gives us 7 over 15. And then with part B, this is slightly different. This is where you can simply multiply your numerators and your denominators. So again, we multiply 2 by 3, which gives us 6, and 3 by 4, which gives us 12. And again, that is equivalent to a half. So now question 20. Here are two squares, A and B. And the length of the side of square A is 50% the length of the side of square B. So that means if A is 1, then B must be 2. And that's because 1 is 50% of B. So let's take a look at a visual representation of this. I'm going to simply go ahead and draw out 4 sections because it's telling us that 1 is half of 2. So that means we have one section, just like this square here, which is the same as shape A. So now we need to express the area of the shaded region of square A as a percentage of the area of square B. And I know many of you think, okay, it's 50% of the length, so it has to be half. Not at all. So what we need to simply do here is, you can now see I've drawn out this square for a reason, and I've divided it into 4 equal parts. So that would be our 3, and then that would be our 4. And now because each square is divided into 2, that means we have 2 parts for each square, and there's 4 squares. So that means that gives us 8 representations here. So I'm going to draw this out here. And again, that's 1, 2, 3, 4, 5, 6, and 7, 8. So again, if we take a look at one shaded space of A, that's going to be 1 over 8. And then again, because they're asking us to express the area as a percentage, we know it's out of 100. So we'll go ahead and multiply this by 100. So then again, we know 100 times by 1 is 100. So we're left with 100 over 8. And again, if we go ahead and simplify this and we half both the numerator and denominator, we've got 50 over 4. We can do that once more, and that's 25 over 2. And then if we divide this, 25 divided by 2, so half of 25, we'd get 12.5%. And that is our answer there. And for those who want to do it a different way, you can simply work out what 1 over 8 is as a fraction, which is 0.125. And then we can go ahead and multiply that by 100. So again, jumping 2 steps, and that gives us 12.5, exactly as what we require. Amazing. Let's now go over to question 21 here. And this is now taking a look at a problem-solving question where we need to find the number of students who walk to school. So again, I'm going to go ahead and draw a table to make it easier to represent my data. I can see there are 40 students in total. So that means I'm going to have a total here. And then I'm going to have boys and girls. So let's go for girls and let's go for boys. Wonderful. And then again, we can see that this is split between walking to school, cycling to school, or getting the bus. So again, I'm going to go ahead here and I'm going to make 3 sections. One which is our walk, one which is our cycle, and one which is our bus. And then let's not forget to go ahead and put in our total here. So now we've gone ahead and done that. They've now told us that there are 22 girls in the class. So I'm going to go ahead and put 22 as my total, which is going to be here. And it also states that out of the 22, 9 girls walk to school. So then again, I'm going to put 9 in my first box. And then again, it states that 7 of the boys cycle. So again, under cycle, I'm going to put 7. And then 6 out of 10 students who get on the bus. So again, because we have our total, I'm going to put 10 in this section, and I'm going to put 6, which are boys. And that's 6 out of 10. So if it's 6 out of 10, we know there are 4 girls that go on the bus. And likewise, we can now work out how many girls can cycle to school. So we've got 9 over here and 4 over here, which gives us 13. And we know that 22 take away 13 is 9, and that is our cycle there. And then again, we can find out the total number of students who have cycled. So again, 7 and 9 gives us 16. So now we need to find out the total number of boys. But if we know that there are 22 girls in the class and there is 40 in total, I'm going to simply do 40 take away 22, which gives me 18. And again, this is your girls and this is your boys and this is your total. So now I know that boys are 18, and we know that there are 7 boys that cycle and 6 boys that catch the bus. So I'll add that together. 7 plus 6 is 13, and then I'll subtract it from 18, which gives me 5. So now I know that 5 boys walk to school. And likewise, I'm going to take the same approach, but simply I can just add on how many students walk. I know that's 14 in total, and I can add up my total here, which is 40. And that is again how you can represent all of your information on a table. And let's go ahead and answer our question, which was to find the number of these students who walk to school. And again, that is our 14 here. So we can scroll down and we can write 14. I hope that was clear. My main tip here would be to go ahead and start off by filling out all of the spaces that you can. Always have a visual representation of the table itself so you can understand what they're trying to say and how you're trying to find out the missing information. And just as we do within a Venn diagram, starting off with what they share, start off in that perspective. Amazing. Let's now dive into 22. Again, this is a probability question. And we now find out that we have 3 different colors, which is blue, red, and yellow. And we need to find out what red and yellow is. So again, what it mentions is that the number of red cubes is the same as the number of yellow cubes. And we know probability is out of one whole. So I'll simply go ahead and subtract 0.2 from one whole, which leaves me with 0.8. And because the red and yellow counters are the same, I'll just simply divide the remaining 0.8 by 2, which gives me 0.4. And I can now fill that in my table. And that's your first 2 marks in the bag. And then it mentions that there are 12 blue cubes in the box. So let's work out the total number of cubes in the box. So we know that 0.2 is equal to 20%, and we know that that is equal to 12. So we need to make 100% in order to get the total number. So again, 20% times by 5 gives us 100%. And again, 100% of cubes will now give us 12 times 5, which is 60. So we know that the total number of cubes is 60. Okay, question 23. So Dion needs 50 grams of sugar to make 15 biscuits. And she also needs 3 times as much flour as sugar. So again, if we have 50 grams of sugar, we need 3 times that much of flour. So instantly, we know 3 times is going to be 150 grams of flour because we've done 50 grams multiplied by 3. And then it states we need 2 times as much butter. So again, we double our sugar, which now gives us 100 grams of butter. And then it mentions that Dion is going to make 60 biscuits. Bearing in mind, this is all for 15 biscuits. So if this is for 15 biscuits, we need to simply multiply it by something, which gives us 60 biscuits. And we know that 15 times 4 is 60. So now because they are asking us for the amount of flour that she needs, we need to multiply the flour by 4. So again, 150 grams multiplied by 4 will give us 600 grams. And that is your flour. 600 grams. However, the next part mentions that Dion has to buy all the butter that she needs to make 60 biscuits. And she buys the butter in 250 gram packs. And how many packs of butter does Dion need to buy? Now we know that from our previous question that our butter was 100 grams. So again, as we multiplied our flour by 4, we're going to do the same thing to 100, times that by 4, and that gives us 400 grams. So if we take a look at the butter that she needs to buy, we understand it comes in 250 gram packs. So if we take 1, it's going to be far too less. However, if we take 2, that will give us 500 grams, which again is 100 grams more, but there's no way we can go to a store and say we just need 400 grams of butter. So she would then have to buy 2 packets. All right, let's now move over to question 24. And this is again a question on your highest common factors. And I'm going to take a little bit of time here just to show you guys the tips and tricks on how to work out both the HCF and the LCM. So it starts off with asking us the HCF of 72 and 90. So I'm going to go for 72 and then I'm going to go for 90. And I'm going to make my factor tree. And this is again the factors that go into 72. But we're only going to pick one factor. So let's go for 2 and 36. So I'm going to go for 2 here and 36. And this is again a factor tree which is based on your prime factors. So we need to find all of our prime factors. And at the beginning we know that 2 is a prime number, so we circle that. But 36 is not. So we go ahead and find 2 factors of 36, which again can be 2 and 18. We know that 2 is a prime number, so we circle it, and we do the same thing to 18. And we find 2 and 9. And again, it doesn't make a difference whether you go for 2 and 9 or 3 and 6. No matter what factor you go for, you will end up with the same result. So again, we know that 2 is a prime number, but 9 is not. So we get 3 and 3, and we know 3 are our prime numbers. So let's go ahead and put that together. We've got 2 times 2 times 2 times 3 times 3, which again, if we write it in standard form, can be 2 to the power of 3 times 3 squared. We then do the same to the 90. So again, I'll go ahead and do 2 and 45, and I'll do 5 and 9. You know that 2 and 5 are your prime numbers, but 9 is not. So we get 3 and 3, and we can write that down. So that gives us 2 times 5 times 3 squared. So now that we've got our prime factors, let's go ahead and put this in our Venn diagram. So again, I'll create 2 circles here. I'll name one which is 72 and one which is 90. And this is where I now need to plot all of my information onto the Venn diagram. So let's start off with what they share. You can now see that 90 has 1 2 and 72 has 3 2s. So again, we can cross out 1 2 from here, and we can cross out 1 2 from here. We'll then go ahead and do the same for the second section. and we'll say, okay, it's got 2 3s. We can cross that out, and it's got 2 3s, which means there's going to be 2 3s in the middle. However, 72 has 2 extra 2s, so we'll go ahead and put that in the 72 section, whilst 90 has 1 5, and we can put that in that section there. So in order to find out our highest common factor, we always have to take the intersection, and that is the middle. And that is what 72 and 90 share. And we simply go ahead and multiply that out. So we have 2 times 3 times 3, which gives us 18. So now we know our highest common factor is going to be 18. But let's take this one step further. What if we are asked now to work out the lowest common multiple, and that's the LCM? Now, in order to do that, we would have to simply multiply everything within our Venn diagram. So by doing so, let's go ahead and multiply everything. So we have 4 in our first section, we have 18 in the middle section, and then 5 in 90. So we know 4 times 5 is 20, and then 20 times 18 is 360, and that will be your LCM. And alternatively, if you don't have this Venn diagram drawn out, you can simply go ahead and write down your 72 and 90 times tables and keep doing that until you get one number that matches, and that will be 360. Okay, moving over to 25. This is again showing us our elevations. They're showing us the front elevation, the side elevation, and the plan. And they're now asking us to draw a sketch of the solid shape. So again, remember, your plan is your bird's eye view. So I'm going to go ahead and draw my plan there. And then I'm going to simply go ahead and draw my front elevation, which, as you can see, has 1, 2, 3, 4, 5. And then my side elevation, which has 1, 2, 3, 4. So again, if I want to go ahead and do this, I could go and draw a line, and then I could simply match it up here. And we know my side elevation was 5, so I can write 5 centimeters, as well as my side elevation here was 4, so I can go ahead and write 4 centimeters. And that is my sketch done of my solid shape. Okay, question 26. So with question 26, they're now telling us that shape A can be transformed to shape B by a reflection in the axes. And it's followed by the translation CD. And remember now, this is where we have X and Y. So we need to find the value of C as well as the value of D. So let's see now how this is being translated. So at first, we know that it's been reflected. So we're going to see how many squares this is away from the x-axis. You can see that it's got 4 in total. So we're going to do the same 4 here. So we know that our 3, 2 will become our 3 minus 2. And we know that our 5, 2 will become our 5 minus 2. So we can simply draw our line from there. And then finally, we can see that our 3, 5 then becomes our 3 minus 5. And we can go ahead and match this all up to our triangle. And now that's our first step there. We then need to see how many times this has moved to become shape B. So again, you can see we've got 1, 2, 3, 4, 5, 6. So it's gone 6 spaces to the left. And we know that's going to be our minus 6. And then it's gone 1 down, which again would be seen as our minus 1. So taking that into consideration, we now know our C is going to be minus 6 and our D is going to be minus 1. And let's now move over to question 27. So we have a shop that sells packs of black pens, red pens, and green pens. And notice that when I'm reading this question, I'm highlighting the key information as I go on. Just so when I go ahead and attempt it, I know exactly what key information I need to look at. And we can see now that there are 2 pens in each pack of black pens, 5 pens in each pack of red pens, and 6 pens in each pack of green pens. And they're now giving this to us in a ratio. So we can now go ahead and write number of pens sold. And we have our black, our red, and our green. And as you can see, we've got our ratio here, which is 7 to 3 to 4. But we know that the number of packs that were sold for black pens was 7. And in each pack, there's 2 pens. So in total, we have to multiply this by 2, and we know that 14 black pens have been sold. And we're going to do the same thing for your red and green pens. So we know they come in packs of 3, and we know that 5 packs were sold. So 3 times 5 is 15. And then again, we'll go for your green, which is 4 times 6, and that is 24. And again, as we do with your ratio questions, we add up the total amount, which then will give us 53 parts. And they've told us that a total of 212 pens were sold. So work out the number of green pens that were sold. So what are we going to do? We're going to find a commonality between 53 and 212. And perhaps let's ask ourselves, how many times does 53 go into 212? So we know that goes in 4 times. So again, we times this by 4. We know we have 212 parts. So again, likewise, we need to multiply out our ratio by 4 and then find out our green pens. So let's go ahead and do that now. So we know 14 times by 4 is 56. We know 15 times 4 is 60. And then 24 times 4 gives us 96, which again would be our answer. So let's go ahead and write this out. And let's now move over to question 28. And this is where we've been given 2 rectangles, and we are told that the length of Q to R is 10 centimeters. So I'll go ahead and I'll write this out. And then we can see that the length of BC is the same as PQ. But because we're not given a value for this, I'm just going to add a variable X to this one here. And then the next thing I'm going to focus on is that the perimeter of the rectangle ABCD is 26. So I'll go ahead and write 26 centimeters here. And the area of the other rectangle is 45 centimeters. And now we need to work out the length of A to B. So again, we don't have this length A to B, so I'm going to give it a variable, which is Y. So the first thing I'm going to do is simply work out the value of BC and PQ. And how are we going to do that? Well, we have our area, which is 45 centimeters squared, and we have our length, which is 10 centimeters. So I'm going to simply go ahead and do 45 divided by 10, which equals 4.5 centimeters, which is our X value. So now we know PQ is 4.5 and BC is 4.5. The next thing I'm going to do is simply put this into an equation in order to work out the length AB. So again, I'll go ahead, and we know the properties of a rectangle is that the opposite sides are the same. So if BC is 4.5, then AD is also 4.5. So let's go ahead and write this out. 2 multiplied by 4.5 plus 2y, because we've got a y at the top and a y at the bottom, and we know this equals 26. So if we multiply out the brackets, we know we get 9, and we add 2y, which gives us 26. And then we go ahead and we take the 9 to the other side. So we minus 9 from both sides. And so we're left with 2y, which equals 26 minus 9, which is 17. And then we go ahead and we divide both sides by 2. And so now we know that y equals 8.5 centimeters. And that is our final answer, 8.5. So what have I done? I've gone ahead and I've divided my area, which is 45, with the value that was given, which was 10, in order to get my width, which is 4.5. I know that these 4.5s link well with both rectangles. And then I go ahead and substitute that information in order to find out the length of my smaller rectangle, which again is 8.5 centimeters. Okay, we're almost finished now. Let's move over to question 29. Again, they've given us a graph of y equals x squared minus 2x minus 3. And they're now asking us for our turning point. And again, if we take a look at our turning point here, we need to simply see where the base of our graph falls. And again, in order to find the coordinates of the turning point, we are going to find exactly where it turns. And you can see now, this is the bottom base here. So we just take our coordinates, which is going to be 1 minus 4. And that again, if I draw this out, 1 minus 4. and that's what we write here. But then they've also asked us to find the roots of the equation. And how do we go about doing this? Well, when they mention roots, we simply need to see where it intersects on the x-axis. So again, if we take a look, we can see it intersects at -1 and it intersects at 3. So we can simply go ahead and write -1 and 3. I hope that was clear. And now that brings me to the end of the past paper. Once again, this was your Foundation GCSE Maths Paper 1, which is a non-calculator paper. We've gone through a range of different questions and a range of different topics. And I hope you now have a better understanding of all of the questions that are required in order for you to pass the exam. If there are any other questions, or if you want me to dive deeper into a specific topic, please go ahead and comment below so I can go ahead and do that. I hope this video was clear, and I hope you feel more confident on these topics. Don't forget to like and subscribe our page. Thank you very much.